Testbed 18, Interactive Instruments, investigated how to share building and energy data via APIs implementing OGC API standards. One API shared a 3D building dataset for the city of Montreal that was created by Steinbeiß and Concordia for 3 source datasets, so that all buildings had a volumetric geometry and important information for energy analysis. The API implemented multiple OGC API standards or candidate standards to make access to the data simple for clients. Multiple types of clients, data formats, and access patterns were supported to cover a range of use cases with the same API. This demonstration will use a web browser to demonstrate the API via the built-in support for the HTML format. Other demonstrations will demonstrate access to the API from other clients, in particular to visualize the data. In general, it should be possible for the energy simulation engine to access the building data via such an API, but this could not be tested during the testbed due to time constraints. For visualizing buildings, the best approach is to access pre-computed tiles at the appropriate zoom level. Each tile includes the buildings located in the tile that should be visible at the zoom level. Clients can access the attributes for each building. The buildings in this map use the OGC community standard 3D tiles. The buildings in this map use the Mapbox vector tile specification. Mapbox vector tiles are limited to 2 dimensions. The building footprints are extruded with the height of the building. If the purpose of the data access is data analysis or processing the data, the building object should be accessed directly with queries to select the buildings of interest. Here we are fetching all buildings in Ville-Marie that were built before 1870. The data can be accessed in various formats depending on the needs and capabilities of the application using the data. The building energy processing service developed in the testbed was used to simulate energy demand for the buildings on Nuns Island in the city of Montreal. The buildings on Nuns Island in Montreal were joined with the simulation results. That is, the simulated yearly and monthly energy demand for each building was provided as additional building attributes. In this map, the building color depicts the specific space heat demand, where green symbolizes low values and red symbolizes high values. How structured values like the simulation results are represented depends on the data format. In Mapbox vector tiles, the monthly values have to be represented as 12 separate numeric attributes, 1 for each month. In other formats, like CityGML or CityJSON, the data can be represented in a richer, structured, and more flexible representation, as specified by the CityGML extension for energy. Different data formats have different characteristics, and the size of the data is one of them. Textual encodings are easier to create and read for developers, but often larger in size than binary encodings. The OGC community standard CityJSON provides an efficient encoding for 3D building data. A third API provides access to more than 1,600 residential building archetypes in Quebec. An archetype is a sample or virtual building that is characteristic for buildings of the same kind. The dataset was compiled as a representative set from actual buildings. Each archetype includes up to several hundred attributes relevant for energy analysis. To find relevant archetypes to estimate the energy demand of some building, we can filter the data using the building characteristics. Here we are looking for archetypes for 2-story T-shaped houses built in the 1990s. We find 7 archetypes that we can also download as comma-separated values. We can now look for archetypes that are similar to my building and use these in my analysis. This concludes the overview of the 3 APIs. To summarize, let's compare the 2 main access patterns that we have used. Tiled access to pre-computed tiles with building data is mainly used to support performant visualization of large sets of data. Through the optimizations for rendering the data at various levels of detail, this access pattern is in most cases less useful for data analysis and processing. For these use cases, selective access to the relevant data using queries, in our case buildings or building archetypes, is typically more appropriate. Thank you very much for watching this presentation on how Interactive Instruments shared building data and building energy data via OGC APIs in OGC Testbed 18.